Page 174, number 11. So for roles to apply, there's three things that have to be true. If f of x is continuous on the closed, differentiable on the open, and the endpoints, the y values are equal to each other at the endpoints. That's the three things we're looking for roles. For MVT, we drop off that last, the y values don't have to be the same. But for roles, the y values have to be the same. All right, so what about continuous and differentiable for our function? Because they kind of go together for this one. Yeah, it is. Why is it? It's a polynomial. So yes, f of x is a polynomial. And a polynomial is continuous and differentiable everywhere, so we don't have to worry about that. I mean, we need to state it, but we don't have to worry about it. F of 1 equals f of 3. Well, that's going to take a little bit of work, but really not too much work because of the way it's factored. Right? If I plug in 1, then I get 0 times two more things, but it doesn't really matter what the two more things are, right? Because once you got a 0 in there, it's 0. F of 3, kind of similar. It's something times 0, so that's 0. Right? I'm really shortcutting stuff here, but it's okay if you're paying attention. So yes, f of 1 equals f of 3. That's true. Okay, so roles applies. Now we're going to figure out where the derivative is equal to 0. Except that I don't really want to take a derivative in this format. I'd rather multiply that stuff out. I mean, like I have to either pay the price in derivatives or I have to pay the price in algebra. There's no getting around it. I think the price is an easier price in algebra. So I'm going to multiply those two together. X squared minus 3x plus 2 times x minus 3. I suppose I could switch to calculus now and do the product rule, but it's still probably easier to do algebra first. So distribute the x to everybody. X cubed minus 3x squared plus 2x. Distribute the 3 to everybody. Minus 3x squared plus 9x minus 6. So x cubed minus 6x squared plus 11x minus 6. All of that's still algebra, but that makes my calculus easy when it's multiplied out like that, because the derivative now is 3x squared minus 12x plus 11. And again, I want to know where that's 0. Rolle's theorem tells me it's equal to 0 somewhere between 1 and 3. If I want to make it really match the book, I'd put C in there, but a lot of times people don't put the C in, they just use it with the X's, and that's fine too. The trouble is, this doesn't factor. Like, we usually like to rig them so they work out okay, but once in a while. So if it doesn't factor, you get to sing the song. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So 12 plus or minus square root of 144 minus 12 times 11 is 132. So that's not terrible as far as square roots go. So 12 plus or minus 2 root 3 over 6. I could divide everybody by 2, but what I'm going to do instead is to split them up and do 12 over 6 is 2, and then 2 over 6 is 3. Because I think that's going to make my life a little easier doing it that way. Mainly because I need to figure out, are those between 1 and 3? Well, I don't know. 2 is between 1 and 3. What about root 3 over 3? Let's see, root 3 is, I'm going to start guessing here. Not guessing, estimating without a calculator. Root 3 is less than 2, right? less than 2 over 3 would mean that this whole chunk of stuff is less than 1. So if I do 2 plus something less than 1, that's going to be smaller than 3. And if I do 2 minus something less than 1, it's going to be bigger than 1. So both of those will work. But that took a little bit of work to get there. So again, roles, 3 criteria, and then f prime equals 0. MVT, 2 criteria, but f prime equals algebra slope. Calculus slope equals algebra slope. All right, 39 or 45. Let's do one of them. Got a preference between those two? 39 is a polynomial. 45 is sine of x, so that's not bad. 41 doesn't have a derivative, so 41 is MVT can't be applied, at least at, or no, can it? Because it's differentiable on the open. So 41 would work.
Wait, but 45 wouldn't.
45 would work because that is continuous and differentiable.
Wait, can you do 45? Because I gave up on that one.
So let's do 45 then. So y equals sine of x from 0 to pi. And we're checking to see if MVT holds, and if it does, find C, find the place where the algebra slope equals the calculus slope. So MVT is continuous on the closed, differentiable on the open, and both of those are a yes, because we know what sine looks like. I'm kind of doing it from a graph. Like sine of x looks like that. That has no continuity issues, no differentiability issues, so we're good on continuous and differentiable. So MVT applies. That means that, again, I don't even think in terms of formulas first. I think in terms of the concept, the calculus slope equals the algebra slope. Or if you're more of the AROC fan, instantaneous rate of change equals algebra rate of change, or average rate of change. So y prime at C, that's what we're looking for, is C. Algebra rate of change, that's algebra slope formula. y2 minus y1 over x2 minus x1. So f of pi, sine of pi is 0. F of 0, sine of 0 is 0. So 0 minus 0 over pi minus 0 is 0. Hey, what else is going on in this problem? This is a special case. I mean, it's in the MVT section, but it's actually a roles problem. But again, you don't really have to worry about roles ever, because roles is just a special case of MVT where the two y values are equal to each other. Because what happens if the y values are equal to each other, then the average rate of change is 0 and it becomes a roles problem. Let's see, I'm just going to derivative this kind of on the fly because that's not a difficult derivative. So I want to know where cosine of x equals 0. Let's see, that would be at pi over 2 and 3 pi over 2. Although, I need to be careful. I only want between 0 and pi, so that means 3 pi over 2 is not eligible. So at pi over 2, the average rate of change is equal to the instantaneous rate of change. Actually, this one would be a good one to visualize because we can graph this. Hopefully. Hopefully you remember what sine of x looks like from 0 to pi. So the average rate of change, there's our algebra slope, equals 0, and the instantaneous slope equals 0 right there at pi over 2. So we almost could have done this problem like graphically. I mean, that's not really what we wanted to do, but we could verify it graphically anyway because it's simple enough to know what the picture looks like and to find the pieces. Alright, let's move on to new stuff for today. I'll post other videos, so if there's more questions, you can find them in Schoology.